Electricity is a form of energy. It is the presence of negatively charged particles called electrons. When the electrons are present but are not flowing, they build up on an insulator, and this is called static electricity. When the electrons are flowing, this is called current electricity, and when they are flowing around a circuit, this is called an electrical current. Electricity is one of the world's largest, widely used forms of electricity, and it powers many of our everyday items and what we would consider necessities, such as lighting, heating, and appliances. So a single cell is a single unit device that converts chemical energy into electrical energy. A battery is normally a group of cells, so this can be used as a power source for an electrical current, and in my artifact, I have used a battery pack, as we can see here. So a series circuit is when all components in an electrical circuit are connected end to end, and there is a single path for the current flow. In the diagram I have included in my presentation, I have shown a light and a motor in my series circuit. The current is only flowing in one direction, which I have also used it to flow from the positive to the negative battery cells. However, in a parallel circuit, there are two or more paths for the current to flow through. This means that the same voltage is applied to each component of the circuit because they are connected to multiple paths. The current from the power source splits along these paths. So in my diagram that I've included shows the light being parallel to each other with the switches, the motor, and the buzzer. So in a series circuit, the more components in a circuit, the less power it will receive. So for example, the lights will dim, the motor won't run as well, the buzzer won't be as loud as it is, etc., etc. The more resistance in a series circuit, the less current. So in comparison with a parallel circuit, the more resistance there is, the more current there is. So in more depth, so in a series circuit, if one component fails, everything else connected to the circuit fails along with it. This is because the electrical current can't flow because the circuit is broken. However, in a parallel circuit, if one component breaks, the rest of the components will work because it branches off into different currents along the circuit and into the one battery source. So in my artifact, I provided a series and a parallel circuit together, but only using one battery source. The series circuit in my artifact shows a power source being connected to my switch, the motor, and the light. Another light is then connected in parallel with another light, as I have demonstrated in my demonstration. With all of the switches, one is connected in parallel with the lights, one is connected to the motor by itself, and then one is connected to the buzzer, making these all a series circuit. By connecting the motor to its own switch, it gave me the opportunity to focus on one specific component of this artifact, and being able to make it move was the end goal. There were issues that did arise when making this, and this was trying to connect the positive and the negative wires to other wires so that the artifact would work. So when I was making the model, it was not working for a while, and I realized I connected the wires not in the right position with the battery, and that's why I didn't start. I was putting negative and negative together. I was putting neutral and neutral together. I realized that when I was putting my wires together, it didn't end up leading to the battery pack, and it was just going to nowhere, and I was getting stressed out as to why it wasn't working. So solving these issues was easy, as I was able to research and look at the examples on how to connect a series and a parallel circuit to a battery source. So my artifact uses the three devices, a bulb, a motor, and a buzzer, along with the switches. The artifact is powered by one battery source. Some expected issues that may arise during the construction of this artifact is there might not have been enough voltage to power up the lights with the motor or lights in another source. So this means if I connected the lights with the motor or the lights with the buzzer and I turned the buzzer on, the lights would dim. So there wasn't enough voltage in the lights or the buzzer itself to be able to light up properly if I connected those things together. Another issue was the motor was moving too fast. So this could be fixed using resistors or a potentiometer, but that was a big issue of mine, is that here we can see it does go way too fast. And it might just fly off.